This is the study guide for Algebra 1, Unit 4, the unit called Inequalities. So we're going to start with some problems about sets. Number 1, they want to say, use the listing method to represent the following set. And this is the elements. They want all the elements that are integers, that's what the I stands for here, that are equal to x is greater than or equal to 5. So they want a list method. So they want you to tell them this number's in a bracket. So when it says greater than 5, it's obviously going to be all the numbers bigger than 5. This line underneath that says greater than or equal to means you're going to include 5 in this set. So the set would look like 5, 6, 7, 8, 9, how many ever you want to write down, dot, dot, dot. All right, so it goes all the way through to the end of numbers, which is never. All right, number 2, they say, which of the following sets would have a graph with an open circle on 7 and a ray pointing to the right on a number line? So let's remember that these kind of symbols, greater than and less than, have open circles because it doesn't include the number it's on. But if you have a greater than or equal to or less than and equal to, that would be a closed circle. All right, also, if it's greater than, you should shade greater than shades to the right and less than shades to the left. So they're looking for an open circle. So that means it has to be greater than or less than. That takes that option out. And then it says, and shaded, pointed right on the number line. So x has to be greater than 7. So this is the one we're looking for. Open circle and shaded to the right. Number 3, they ask you to graph the following solution. X is greater than or equal to 4. So we're doing this in reverse. You're going to make a number line, or you're going to choose the correct number line. Here's 0, 1, 2, 3, and 4, right? And it says x is greater than or equal to. So remember, greater than or equal to would be a closed circle on 4. And you're going to shade greater than, shades to the right on the number line. So all the numbers to the right of 4 should be shaded. Problems number 4, 5, and 6. On number 5, they say, 4, choose the solution set. So you're just going to solve this. Remember, this acts as your equal sign. It's just an inequality, which means not equal. It still acts as equal sign. So if you move anything across you want to isolate x and get everything away from it. So if you move anything, the sign, it performs the opposite function. So right now, it's x minus 5 is greater than negative 3. So the opposite of minus would be add. So we're going to add 5 on the other side. So it's going to say x is greater than or equal, not equal to, negative 3 plus 5. So x is greater than 2. All right, remember this sign doesn't change unless you have a coefficient that's negative here. All right, number 5, same thing. They give us a fraction to do with. And so the easiest thing to do is multiply by the common denominator. Actually, we're going to multiply by negative 2. It'll change these signs. So the 2's cancel here, and a negative 1 times a negative 1 is a positive 1. So positive x. This sign flips because you're multiplying by a negative. The sign flips over, and then you have negative 2 times 4, which is negative 8. So the final answer is x is less than negative 8. On problem number 6, same thing, but then at the end they want you to graph your answer. All right, so we're going to solve for x. The 3's added to x. So the opposite function of adding is subtracting. So the first thing we're going to do is go 3x is less than 9 minus 3. Now 3x is less than 6, and then the 3 divides. So x would be less than 6 divided by 3. X is less than 2. Oops, so now we're going to graph this. So it's less than, which means it's going to shade to the left, and it's just a less than sign, which means it's an open circle. So we should have here 0, 1, 2 on the number line, negative 1, negative 1, negative 2, right? So it's x is less than 2. So an open circle, because it's not less than or equal to, it's just less than. And less than always shades to the left of the number line. Number 7 and 8, they give you two equations with multiple variables. The same one, but x in there two different times. So it's just a little bit bigger problem. The same applies to this as the previous ones we did. This is your equal sign, and you're just solving for x like you would if there's an equal sign there. So you're going to move all your variables to one side, your constants to the other, and isolate x, all right? So here we have 7x plus 1, and here we need to do our distributive property, okay? That's when a number is multiplied to a binomial, or two terms in parentheses. You have to multiply the 4 by the x, which gives you 4x. Then you have to multiply by the 4 by the negative 5, which gives you a negative 20. Now we want to put all our x's on this side and our constants over there. So we got 7x here, and we're going to move over this 4x. It's positive, so on this side it would be negative 4x. This sign stays the same. You have a negative 20 over here. This 1 is added, so over here it's going to subtract. So now we have 7 minus 4, which is 3x, is less than negative 21. All right, and then when you move it over and divide, it's negative 21 divided by 3, which gives you a negative 7. Now, if this 3 had been negative and we moved it over, our sign would have flipped. But it does not, because this 3 isn't negative, okay? All right, problem number 8. Same thing, we have to do distributive property twice. So 4 times x is 4x. 4 times negative 3 is negative 12. Watch for your negative signs. They make a difference. This is negative 2 times x, which gives you a negative 2x. The next one is negative 2 times a negative 1. Two negatives make a positive. 2 equals 0. All right, let's combine our like terms on this side. We have 4x minus 2x, which gives you 2x. Then you have a negative 12 plus 2, which gives you a negative 10. It's not an equal sign. It should be a less than sign. I'm sorry, a greater than sign. Here. 0. All right. Now the 10 needs to move to the other side so we can start isolating x. Here it's negative, so when it moves over, it becomes a positive 10. And then we're going to divide by the 10, 2. So 10 divided by 2. X is greater than 5. Number 9, they want you to write the correct sentence for this. X must exceed 12. All right, so x is your variable you're going to use, and it says it has to be greater than 12. It must exceed 12, and it doesn't say it can be 12. So it can't be, it's not greater than or equal to 12. It's just x is greater than 12. It has to be bigger than 12. Number 10, they ask you to write a sentence for the problem. 4 times a number is at most negative 7. So you have 4 times the number, which is 4x, and then at most it can be negative 7. So it can be negative 7, but it can't be any bigger than negative 7. So it has to be negative 7 or under. So it's got to be less than or equal to negative 7. It's the highest number it can be is negative 7. Now we're going to do some problems with sets. They ask you on number 11 to find the intersection. That's what the upside down U means. The intersection of A and B. That means what is in both A and B. So A contains 4, 7, 10, 13, 17, and B contains 3, 5, 7, 9. So the only thing common in both of them is 7. So their intersection is 7. On number 12, they ask you to find the statement, which of the following statements is false between these two sets. So they say these are subset signs. So it says an empty set is a subset of A, B is a subset that is equal to itself, and A is a subset, that is not that line. B is a subset of A. So remember, a subset contains sets that, elements that are only in another set. So what we need to realize is that every set has 2 set subsets. Every set is a subset of itself. So B, yes, it is a subset that is equal to B. Every set is a subset of itself. And an empty set is a subset of every set. All right, so these both are true. An empty set is a subset of A because an empty set is a subset of every set. B is a subset that's equal to itself because every set is a subset of itself. Now, B is a subset of A. B contains numbers that aren't in A. It has 7. That's the only thing common. So for B to be a subset of A, it would only be able to have 4, 7, 10, 13, and 17 in it. So B is not a subset of A. That is false. Okay, problem number 13 is a little word problem. It says, Haley's car gets 18 miles per gallon. If she plans a trip that is 300 miles, what is the minimum number of gallons she'll need? So remember, for distance problems, rate times time equals distance. So they want to know, if she gets 18 miles per gallon, how many gallons is she going to have to buy to equal 300 miles in her car? All right, so this is what we're solving for, x. We want to know how many times, sorry, it's not a rate times time equals distance problem. It's just a simple division problem. 18 times what equals 300? So just take 300 divided by 18 and you'll have your answer. All right, in problems number 14 and 15, we're going to do some intersections of sets on the number line. So they want on number 14, the intersection of x is greater than 4, less than 4, and x is greater than -2. So you just need to plot these on the graph. Here's your 0, 1, 2, 3, 4, and -1. All right, so x is less than 4. So it's on 4, positive, and it's less than, not less than or equal to, so that means it's an open circle, and it's shaded to the left, all the way down this way, all right? It actually goes on and on, right? All the way to the end of the number line. The other one is x is greater than -2. So again, open circle on 2, and it's greater than, so it's going to be shaded all the way to the right. But the intersection is only what's shaded by both. So it's going to have open circles on -2 and 4, and a line segment between them. All right, same thing on number 15, but they want you to solve these first. So x is plus 2 is less than 5, so the 2 is added. On the other side, it's going to subtract. 5 minus 2 is 3. And on this side, it's a -7, so on the other side, it's going to add. -6 plus 7 is 1. So now they want you to do the intersection of x is less than 3 and greater than 1. So here we are, 0, 1, 2, 3. All right, so x is less than 3, so open circle on 3, shaded to the left, and greater than 1. So open circle on 1, shaded to the right. So their intersection is an open circle on 1 and 3 and shaded to the right. It can be written like this as a compound inequality with the x in the middle, and say x is greater than 1 and less than 3. That's how you would write it, as in compound inequality. Problem number 16, they asked, which of the following solution is a solution of y minus x is less than -3? So they give you 3 points, and they just want you to put these points into this equation, y minus x. So in the first problem, option, 6 and 2. Y is 2, 6 is x, because remember in your points, x, y, like this. So 2 minus 6 is less than -3. 2 minus 6 is -4, is less than -3. Is that true? Yes, it is true. In negative numbers, the bigger integer is actually smaller. -4 is less than -3. And number 17, they want you to graph the following inequality. Now this is a line. You can tell because it has an x and a y. All right, so we need to solve this. In your last unit, you learned about plotting points on a graph. So that's what we're doing here. We're going to put this in slope-intercept form. In slope-intercept form, y equals mx plus b. So that means we need to move everything but y to one side of the equation. So we're going to leave the -2y right here. Say greater than or equal to, the 3x is going to move over here. So it's going to become -3x plus 6. Now for y to truly be isolated, we have to move this -2. Now this 2 is negative, meaning when we move it over that sign, actually when you do your line, we know it's going to be a solid line because of this. When we do this part, we'll just use an equal sign. All right, we'll use our inequality here in a few minutes. We just use an equal sign when we solve for y, all right? So the y stays here is equal to -3 divided by -2x, and 6 also divided by -2. We have to divide both of these by -2. So y equals +3 over 2x minus 3, because 6 divided by -2 is -3. Now I'm going to erase this. This is our line we're going to graph on the chart, all right? So in y equals mx plus b, b is the y-intercept. It's where a line crosses the y line. So this tells us it's going to cross the y line at -3, which is going to be here. All right, so there's our y-intercept, and then we're going to use this, which is our slope, 3 over 2. Slope is equal to rise over run. If they're both positive, it goes up and to the right. All right, so +3 over 2, the rise is a +3. 1, 2, 3, and a run of 2, 1, 2. So there's our 2 points. It's going to be a solid line, kind of crooked, but a solid line, not dashed, because it had a greater than or equal to sign in it, right? Now we have to decide what side this graph is going to be shaded on, because it's inequality. It's either equal to this or that. So we're going to pick a point. I love this point right in the middle, 0, 0, and you're going to put it back into the original equation. You're going to say, let me erase this real quick. The original equation is 3x minus 2y is greater than or equal to 6. So we're going to say 3 times x, which is 0, because we picked point 0, 0. 3 times 0 minus 2 times 0 is greater than or equal to 6. So 0 minus 0 is greater than or equal to 6. 0 is greater than or equal to 6. That is not true. 0 is not greater than or equal to 6. So that side of the graph is wrong, because that's where 0 is at. This side is what needs to be shaded. Number 18, 19, and 20, not 2, deal with absolute values in graphs. So remember, absolute value means everything's positive. Absolute value is just talking about the distance from 0 on a number line. So the absolute value of 7 and -7 are the same because they're both 7-point distance from 0 on the number line. So when you're graphing this, x, absolute value of x equals 7, it means x is equal to positive and -7. So you just, because it's equal, you're going to put a solid dot at 7 and one at -7. Now, when you have an inequality with an absolute value, it does mean that it is less than 3. You show your positive, you keep your sign. So when you show the positive, you're going to say, keep the sign 3. Then when you show the negative, your sign's going to flip. So this would say x is less than 3, x is greater than -3. All right, so then to graph that, here's 3, here's -3. X is less than 3, so it's open circle on 3, shaded this way, and greater than -3, going that way. All right? Number 20, it's a little equation. So when you have absolute value of x plus 1 is greater than 2, you deal with solving for x first and then mess with the absolute value. So the first thing we do is move 1 to the other side. So you still have the absolute value of x. The 1's going to subtract is 1. So the same thing happens here. X, you keep your positive, you keep your sign the way it is when it's positive. So this would say x is greater than 1, but x is, flip the sign, less than -1. All right? And then you just need to graph that on a number line. All right, problems number 21, 24, and 25. We're going to work on those. We'll hit 22 and 23 here in a minute. They all deal with the graph of y equals the absolute value of x. So if you'll remember this from last unit, y equals the absolute value of x is a v that opens up from the center. V like this, absolute value of x. V that opens, if it has a negative, it opens downward. So this would look like this right here, right? And then we learned about translation. So if there's a number added outside here, outside of the absolute value, or subtracted outside, that tells you whether it goes up or down. So in this case, plus would move the vertex up 4. If it's minus, it would move the vertex down 4. And then if it's inside absolute values like this, it moves it left or right. And it's actually backwards, so right would move it, plus would move it to the left, and a minus would move it to the right because it's inside absolute value. So that's what we're dealing with here, but with inequalities. Also with inequalities, if it says greater than, then inside of the V is going to be shaded, and if it's less than, everything outside of the V is going to be shaded. So they asked you to graph this on number 21. It's a V that opens up, it has a dashed line, so that tells us immediately we're not going to have an greater than or equal to or less than or equal to. We're just going to have a less than or greater than. All right? And then it is moved, the vertex has moved 1, 2, 3 to the left. So in a translation of this graph, left and right is inside absolute value, and they're backwards. So if it moved to the left, you're actually going to add 3. All right? And then the outside of it is shaded, not what's inside. So that means it is less than. Y is less than the absolute value of x plus 3. Number 24, they want you to tell, okay, what am I going to do with this? So remember, it's shaded. It's added outside, which says up or down, and it's positive, so it's going to move up. So you're going to translate it 4 units up. It's going to be a solid line because of the greater than or equal to sign. And because it's greater than, it's going to be shaded inside the V. Everything in and above it is greater than it. All right, problem number 25, they give you an equation and they want you to say which point fits in this graph. So we just have to try them all. So y equals the absolute value of x. Our first point is negative 3, 1. So we're going to say this should be a greater than sign right here. There you go. And y is greater than, we're going to try the first point. So y is 1. 1 is greater than the absolute value of negative 3 This is a minus. I knew something was wrong here. Excuse me. Okay. Absolute value of 3 minus 4. So you're going to say 1 is greater than 3 minus 4. 1 is greater than negative 1. Yes, that's right. So this top one is correct. I believe it's marked that this one is correct on your study guide. That is not true. The top one is the one that is correct. All right, 22 and 23 are a little bit tricky. On problem 22, they want to know which solution set is all real numbers. So they want to know which one of these covers the whole graph. And in 23, they want to know which one covers none of the graph. So the word and, hold on, we'll do 22 first. 22, so you just need to plot these on the graph. Remember, with absolute value, it is and an inequality sign, you keep the sign for whatever's there, and when you change the sign, it becomes, the sign flips. So this would be x is less than negative 1, and x is greater than positive 1. And this one would say x is greater than negative 1, and x is less than 1. All right, and then this one, the absolute value of x equals negative 1 is impossible. You can't have an absolute value equal a negative number. All right, so we got to see which one of these covers the whole graph. So the top one, x is less than negative 1, is 0. Here's negative 1. It's a less than, so it's going to be open circle and shaded that way. And greater than 1. So it doesn't shade the whole graph because it's missing this part in the middle. But the one beneath it says x is greater than -1, so open circle here shaded that way, and less than 1. So this one covers the whole graph, so that's all real numbers. Number 23, they give you 3 options here. They say x is less than 0 and x is greater than 0. They say x is less than or equal to 0 and x is greater than or equal to 0. And they say these two both say and the bottom one says x is less than or equal to 0 or x is greater than or equal to 0. All right. So they want to know which one has no solution. So because and is an intersection. So this one is greater than or equal, less than or equal to 0 and greater than or equal to 0. So they both have a closed circle on 0. And it's greater than and less than. So they do have a solution because they both are equal to 0. But this one, see, and they both have an open circle on 0. It's less than 0, greater than 0, and an open circle on 0. So they have no solution. They don't cross at any point. A number cannot be greater than and less than 0 without being equal to 0 as well. All right, so that covers our study guide. Study real hard. Shouldn't be too difficult. Make sure you know what you're doing when you get to your test.